All right, so today what we're going to do is we'll take a look at scientific notation first, and then we'll do sig figs. So we'll start with just scientific notation. If you ever can't read anything I write up here, let me know. My pick and scratch gets worse even when I use the tablet. Okay, so might become a little bit harder, more hard to read even. Okay, but the idea here is right, like scientific notation, we're going to be expressing numbers as a product of 10, right? And it's a great way. It's it's great for really big numbers and really small numbers, right? Okay. It's great for really large and small numbers, right? Because it just makes your life easier. You don't have to write out like all sorts of 20 zeros or whatever, okay, or whatever it might be, okay. So, and just to kind of review, well, I'm just going to do a couple, I'll have you guys do a couple examples, and hopefully that'll be all we need, okay? Because everybody's seen scientific notation before, right? Okay, all right. So let's say we have a number, and we want to go to scientific notation. Sci Not, all right. So if we have something like, I don't know, 10,000 meters, and we want to go to scientific notation, how would I express that in scientific notation? Yeah, Rohan?
You could do 1 times 10 to the 4th power.
Very good. Okay, so I'm going to do this, just kind of get in the habit of doing this. And I'll talk about this in a little bit of why I put 3 digits there. It kind of goes to significant digits. All right, and what we're going to do in this class, we're going to round the 3 sig figs. But so we took the decimal point, which is right here, right? It's not present in that number in 10,000, but we know where it's at. And we moved it to the left 1, 2, 3, 4 places, right? So that's why it's 1.0 times 10 to the 4, right? Okay, all right. And then what if we do, I don't know, mother's is a small number. How about 6, 7? How about that? All right, so what'd you come up with for this one?
1 times 10 to the negative.
I'm going to do 3 there. And if you just put 1 times 10 to the minus 9, that's fine. We're gonna round things to 3 sig figs here in a minute, so I'm just kind of getting that habit already. All right, very good. Okay, so what do we notice here? Right? What do we notice here? What's the difference when we get scientific notation?
When you move the decimals to the left, it's a positive exponent, and when you move the positive scientific notation. When you move it to the right, it's negative.
Okay, yeah, we got this positive and negative stuff going on, right? So just to kind of I'm just gonna put that out here. All right, so when we got a positive exponent, right, we're talking about large numbers, right? Because so we're moving it, we're gonna move things to the right. And if we've got a negative exponent, right, we're talking about small numbers. Okay. All right, and then let's just do just kind of one more example of this. How about if we took 4, 2, 0.21650. And I want you to round that to 3 digits like we've been doing here. Make sure we have 3 digits over there. So I want you to round that to 3 digits there with scientific notation. Okay, so we have 3 numbers in our scientific notation. Caitlin, do you have a number? Oh, okay. Right. 4.2 times 10 to the 6. So why did you go 4.22? Great. So round it up. Right, you round it up because that number is greater than 5, right? Okay, we want to be able to round numbers as well when we're doing this. Okay. All right, so let's just take a couple out of scientific notation real quick. We'll go from scientific notation to a number. Let's do 2 of those real fast. How about 0.0123? Oh, whoops. That's not what I want to do. I want to go from scientific notation to something else. How about 10 to the minus 7, and then there we go. So take those from scientific notation to a number. You got something? Yep. There you go. Want to write that first one in there? There you go. Feel free to, you can touch the screen and stuff when you write. Okay. Makes it more comfortable. Everybody happy with that? Does that look all right? Okay. All right, Clark. Yeah, next one. All right. Sweet. Not bad. Zoom out a little bit for that one. Oop. All right. Everybody okay with that? Any questions about that? Are we good with scientific notation? All right, that's a mole. That's the number of a mole. That's how we count atoms and stuff in chemistry here. So that's why it's up there. That's why it's up there too. Big massive number, right? Okay. We'll learn about that in a little bit here too. But all right, we good? Scientific notation. Any questions? All right, beautiful. Okay. And that's why this is a lot easier than that, right? Okay. We deal with really big numbers around here, and we also deal with real small numbers too. So we want to be able to use scientific notation. Okay. Moving on to significant figures here. Okay. I don't know where that line came from. Significant figures. All right. So significant figures. What we're talking about here. It involves measurement. Okay, just so we understand that. And so what's important there is the type of measuring device. Determines the number of sig figs. I kind of abbreviate significant figures as sig figs. Okay? So it deals with measurement. And with all that being said, we're always going to round to 3 significant digits in this class. Okay? So it's kind of a little caveat in here. We really used to pay a lot more attention to significant digits, but in the grand scheme of things, in the reality of it, ultimately at our level, if we can round all of our answers to 3 significant figures, basically to 3 digits, that's good enough for us. Okay? So in this class, round answers to 3 sig figs. Okay, to 3 sig figs. Yes?
Does that include the numbers before the decimal?
We're going to talk about how you count them and what determines what a significant figure is. Okay, but ultimately, what I want to impart on you here, though, is every device we use, okay, to measure something has a particular amount of accuracy where we know it can only read to so good, right, to as close to the true value as possible, right? The more accurate the device, the more significant figures we get, okay, because we're closer and closer to the actual true value of that particular thing that we're measuring. So the example that I have over here on the side that I was using before was that, all right, we have this ruler, right? We have one ruler up here. It's only marked off every little bit there. And in the next ruler, oh, it's marked off every 10th. Okay? So if we read this value, what does that read at? What's that? 1.5 about, right? Okay. So that works. So you read the 1, right? How'd you get the 5? So, but what are you doing though? You don't know that it's bingo. That's the key. You're estimating that last digit. You got to estimate between the hash marks, right? Okay. We can't read this true value any more closer. Okay, that's as good as that device can give us. It's only got 2 significant digits there. Okay. Where if we look at this device here, you can see it's not quite on that line, right? So maybe David, what would you read that as there? 0.4. Keep going. It's a little in front of that line, actually. 1.38. There we go. Okay, so these first 2 digits you could read. You know it's at least 1.3, but then you estimate that last digit. Okay, anything beyond that, we don't know. Okay, we don't know. Okay, so this ruler gives us more significant digits. It actually gives us 3 because it's a more accurate measuring device. Okay, so look, I'm a track coach, right? Okay, so when we're talking about measurement, all right, and you're talking about timing a race, for example, okay, or if you're actually out there and you're throwing an implement, you have different rulers, okay, that you can use, but they all use the same measuring tape, okay? But when you're at the timing, you know, everybody's sprinting for the 100-meter dash, right? You see all these guys coming across the line, and it's just so fast, right? Might even look like they're tied. But the device measures, and we have such accurate measuring devices now that they can measure to the thousandths of a second, okay? They have an electronic gun that they use. It sends an electronic signal, so it's instantaneous. We'll start the watch, okay? And then there's a camera on the finish line that takes a picture, 1,000 pictures in 1 second. 1,000 pictures in 1 second. Okay, that's how accurate it is. So we're good to that point, that moment. Like, I don't know if you ever seen an old Olympics from like the 50s or something. They only have tens place for a decimal. Okay, but we need more and more accuracy and precision. Okay, because you need to be able to replicate that timing ability. Okay, so, but in any event, significant figures are all dependent on the device we use and stuff. And there's a particular amount of error associated with every measurement and all that sort of stuff. But today we're just looking at counting the number of sig figs in a number and rounding it to 3 significant digits. Okay, so first thing we got to be able to do is count. How do we count sig figs? All right, so count sig figs. It's a really good rule. Really easy, okay? You guys saw your particle pictures. Drawings are bad. I'm going to draw the United States right now. And that's the United States. Thank you. Okay. All right, we're right here. Right, we're right there. That's like Lake Michigan. Okay. All right, that works. All right, there's Florida. This is all the rest over here. Okay. Okay. So what we're going to do, well, I mean, hey, if I were to ask you which side's the Atlantic Ocean on, which side's the Atlantic? Yeah, so, right, you know it's America, okay? All right, so Atlantic, okay? And which side's the Pacific? The left, right? The left coast, okay? So there we go. All right. And what I'm going to do in the middle of Oklahoma here is I'm going to draw a big decimal. One day they'll make a big decimal mark and you'll be able to visit and be like the world's largest decimal point. And they'll have a little instructional video about how to count sig figs. Okay, that, right? Pretty awesome. Okay, so have any of you guys ever been to like, is it Casey or Alton down south there a little bit? It's just, it's right outside of Charleston. They have like 4 or 5 of the world's largest things right in town, and town is tiny. They've got the world's largest rocking chair. It's humongous. The world's largest like thimble. The world's, I mean, like it's crazy. They're humongous items, and it's in this tiny little town. It's really funny. You should go there. All right. So in any event, if you're passing by, it's worth checking out. It's kind of interesting. So this is the deal. There's really like one rule and then like a couple caveats with it. So this is what we break it down to. For first thing you gotta do is look for the decimal. Okay, you gotta look for the decimal in the number. Okay, if it's present, right? We got present and absent. Right, so this is why I drew them up here. Present and absent, so Pacific and Atlantic. Okay, so if it's present, you start counting on the left. If it's absent for the Atlantic side, you start counting on the right. Okay, you start counting on the right. And we'll put this into practice in just 1 second. A couple caveats. Never start counting with a 0. Okay, and the other caveat here is kind of like eating, what is it? Is it Chex Mix or something? Once you start, can't stop, right? Okay, so once you start counting, don't stop. Obviously, until you run out of numbers, right? All right, until you run out of numbers. Okay, so it's pretty straightforward here. So let's do a couple quick examples. All right, so first example is something like this. Okay, so I have 0.0001204. All right. First thing we gotta do, look for the decimal. Present or absent? Present. Okay, so that means we're going to the left side of the number. Okay, going to the left side of the number, and we're going to move in the number from left to right. Okay, so from Pacific to Atlantic. All right, so can I start counting with 0? No. All right. 1, 2, 3, 4. I'm out of digits. That's it. We got 4 sig figs. Okay, 4 sig figs. We don't include the zeros there because they're just like placeholders. They're just placeholders. Okay, that because it's a like this number is a whole lot different than 0.124, right? We have to have the zeros there to make sure we're representing the proper number. Or maybe like something like this. Okay. 7,200, or yeah, 700,000, 2,100, right? So decimal point, absent, right? Starting over here, can't start with zeros. 1, 2, 3. Three seconds. All right. Yep.
You had some number that was like 2.0043 or something
Like that?
Yeah.
Okay. So decimal point is present, right? Okay, so we start on the left. We got a number here, so it's once we start, we don't stop. All right? 1, 2, 3, 4, 5, 6. 6. Okay. And what we're ultimately going to be able to do, what we want you guys to do in this class, is ultimately we're going to round everything to 3 significant digits. We're going to want to round everything to 3 sig figs. Okay. So, and the reason why we're going to do that is, for example, do you guys remember density from like junior high? Formula for density? What's involved with density? Oh boy. So failing. Right, density is mass over volume, right? The amount of stuff in a particular amount of, right? In a particular area. The blank in a 10-pound bag, right? Okay. Very dense bag. And so if you have, let's say, for example, we measure something out. It's got a 10.12 grams. It has a mass of 10.12 grams. Maybe its volume is, I don't know, 7.65 milliliters. Can somebody work that on their calculator real quick? My calculator, phone, calculator, either way, fine. This is what I kind of want to, this is the reason why we're going to do this. Okay, perfect. Perfect. See, it spits out this. Your calculator will go 1.322875817. All right, and then that's what you're going to give me for an answer, because your calculator sets up. Okay. But the problem with that, and that's grams per milliliter. I can't forget my units here. All right. The problem with that is a number of these digits are no good. Okay. They're not significant. They're uncertain digits. Okay. We look at our digits here, our measurements, right? We have, you can see on the silver nitrate, seeing my fingers. This number here has 4 sig figs in it, right? The number here on the bottom has 3 significant figures in it. When we do a calculation with significant figures, your answer is only as good as the smallest, it's only as good as your measurement with the least number of significant digits. Okay, so in this case, our answer really is only good for 3 significant digits. Okay, anything beyond that is uncertain. Okay, we don't know those answers. It could be right, but it could be way different. All right. So in this case, we would round this to 3 sig figs to 1.32 grams per milliliter. All right. We got 3 sig figs there. The 4th digit is less than 5, right? So that's why I left it as 1.32. Okay. Okay with that? All right. So that's ultimately why we need to be able to count around sig figs, because of that. Yep.
So if that works for any operation, like here you're dividing, is that the